Hey, we're going to finish up our discussion of fossil fuels. Some of this information in this particular lecture is not found in the textbook, so it's going to be really important you guys get your notes out to take care of this, okay? So real quick review of where we left last week with our in-class discussion and note session. We talked kind of about the lifetime or life cycle of oil and natural gas particularly. We said, it's really difficult to determine, because it kind of depends on what type of oil we go after. Right? There's some of that oil in our tar sands and that oil locked up in shale, and whether or not we decide to go after that and how the horizontal drilling and fracking thing goes. And so there's a lot to consider there. So it could be anywhere from 40 years to a couple hundred years, just depending on what we decide to do. All right? But that easy to get oil, that is likely to run short during this century. And that's an important point to make there, okay? So let's move on. Non-traditional fossil fuel sources. Again, this is still a review, right? We've got things like tar sands, which we have the oil locked up on sand grains that has to be heated with steam to release that oil. Oil shales, very similar to the tar sands, the oil stuck inside rocks as opposed to underneath rocks. Gas hydrates are those crystals of natural gas and water that when it's real cold and there's a lot of pressure. And of course offshore oil, which we actually already are accessing to various degrees, although we're not accessing it so much, in the Arctic Ocean where we think there's quite a bit to get after. All right. And then pros and cons of going after those. We could extend the lifetime of our fossil fuels for a really significant amount of time if we go after them. Although they become more problematic, we're more likely to have accidents. And then, of course, there's the whole climate change debacle that we're trying to resolve. Okay? Now, if we look at historical U.S. oil production, right, we saw that around 1970, we see our peak of production. All right? And then a kind of a slow, precipitous decline shortly after, up through the early 2000s. Right? Then oil prices went up. We saw a big boom in hydraulic fracturing. Okay. Now this is a way that we can go after both natural gas and oil differently than we used to be able to. So what I want you to do is to go to this link right here. Okay. I will do my best to actually make a link to it in this video for you. Should be a little pop-up there. But go to that link and I want you to watch that animation. It's about 6 minutes long. Go to it, watch it, and that explains what happens during the hydraulic fracturing process. And it's a little bit propaganda-ish. It is put out by an actual hydraulic fracturing company. So, of course, they're going to talk about how it's perfectly safe and there's no problem with it whatsoever. But it is a very good explanation of the actual process itself. Okay? Now, after you've watched that, come back to me and we'll talk about some of the issues with hydraulic fracturing. We'll actually get to those in class as well. But, so watch that. Pause. Go watch it right now. Do it. Okay. Now you should be back after having watched that video. Now, some of the issues with hydraulic fracturing is ground or surface water contamination. Now, in some cases, because of that fracturing process and the oil the drilling itself, the casing gets leaks. There have been incidences where people who get their water from groundwater have actually pulled up water that has natural gas in it. So you may have seen on YouTube or on the internet people being able to actually catch their sinks on fire because of natural gas coming out with the water in their faucet. All right, some of that is linked to hydraulic fracturing nearby. Also in Oklahoma, they're having a crazy number of, small to medium earthquakes that are linked directly to this hydraulic fracturing process and pumping water back underground and weakening the areas where there's stress. Okay, so main concerns with hydraulic fracturing are one, the contamination of water, two, earthquakes, but also its carbon footprint is much larger because there is some leaking of natural gas directly into the atmosphere, and natural gas being mostly methane, and methane being a very potent greenhouse gas. The carbon footprint, particularly the greenhouse gas footprint of fractured oil or natural gas gotten through hydraulic fracturing is significantly higher. Okay. Now, it is worth saying, though, if we look back at the history of oil production, right, we saw that precipitous decline after the 70s, okay? When oil prices got high enough and technology was able to take off, we saw this big spike in oil production as a result of hydraulic fracturing. Now, prices have gone down a little bit, and so likewise, so has oil production, but we're still much higher than we were just a few short years ago. Now, environmental impacts of oil and natural gas, exploration and mining and extraction, okay? First of all, we know when we burn hydrocarbons, we get carbon dioxide. So there is, of course, that link to climate change. We're stating, though, that natural gas of the three fossil fuels, by far the cleanest. It does still produce CO2, but less than both oil or coal. And it doesn't have all the other byproducts associated with those. In getting the actual resource out of the ground, not nearly as destructive as coal mining, at least not for our traditional wells where we drill and pump. Okay, although the tar sands and the oil shale, that's a mining operation very similar to coal. But there is still disturbance to land and habitat. Now, unlike coal, because oil particularly is a liquid, it needs to be transported differently. There's a much higher issue, a much bigger issue if things spill. All right. And so during the spill, we had the Deepwater Horizon oil spill off the coast of Louisiana. And then, of course, we also have the Alaskan oil spill in 1989. We'll talk about each of those next. So in 1989, the Exxon Valdez hit a reef, right, and spilled 260,000 barrels of crude oil into the Sounder. Now, that devastated the fishing industry. The Deepwater Horizon oil spill, which we'll talk about next, actually put more oil into the water. Not nearly as destructive, partly because of the type of oil that it was. This is a really tarry, very, very viscous oil that sat on top of the surface and really choked out a lot of wildlife. In fact, the settlement from that oil spill is still being paid out to some of the fishermen up there in Alaska. Okay, so even though the Deepwater Horizon killed more people and also spilled more oil into the water, it was not as destructive as the Exxon Valdez oil spill. Okay, the Valdez oil spill did lead to the Oil Production Act of 1990, which basically puts it, these companies that produce the oil and transport it, it is their responsibility to compensate in the case of a big accident like that. So Exxon had to go back and basically pay salmon fisheries and et cetera, everybody that relied on the sound there for their livelihood. Exxon Valdez had to pay billions and billions of dollars, as did BP after the Deepwater Horizon oil spill, because of this Pollution Act of 1990. All right. Now, in 2010, this was not a transport issue. The Deepwater Horizon oil spill was actually an issue of at the production site. So they have these oil platforms, and I'll show you a picture here shortly, way out underground that do the actual drilling and pumping, and then tankers bring it in. This accident actually occurred on the oil platform. So there's a blowout preventer. So they kind of have all these little fail-safes in these big wells. And the blowout preventer failed, and it allowed high-pressure oil and natural gas to abruptly travel up the drill housing to the rig, after which it was exposed to some sort of spark. And there was a massive explosion. The explosion killed 11 workers, and then because the well itself broke, it allowed oil to just pour out for months into the Gulf of Mexico there. So here's a picture of that actual oil platform out there, and where the casing and stuff broke deep underneath, oil just poured out into the sound. So here we can kind of see where the origin of that spill is, and then the currents carried that out, and we can see the total area covered by that oil spill is pretty dramatic. Now, even though, again, like I said, it was more oil, that type of oil that it was made it a little bit less problematic to clean up than the Exxon Valdez. Okay, so here's a picture underwater, and you can just see months and months where that oil just poured right out of the bottom where that shattered pipe occurred. And you can see here this oil is not nearly as black and thick as that oil you saw in Exxon Valdez oil spill. Okay, but BP, British Petroleum, the company in charge of that oil well, had to pay compensation to all of those people that rely on shrimp and fish and so on off the coast of Louisiana and Mississippi. All right, now moving on. So as we talk about oil and getting oil from other places, one point that's actually coming back into play, this kind of had been settled for a while, the Arctic National Wildlife Refuge up in Canada. There was a big kind of controversy over whether or not we should be allowed to explore for and drill for oil in that wildlife refuge. Now, the way law is written, wildlife refuges don't have the same type of protection that like a wilderness area or a national park has. So basically, the way the law is written is companies can go in and drill for oil and extract natural resources as long as they don't disrupt the purpose of the wildlife refuges. So if they can go up there and not destroy habitat and not cause a decline in caribou populations, etc., they by law are allowed to. But lots of people didn't want that at all, and so there's a big controversy back earlier in the 21st century, kind of the mid 2000s there. But it's becoming a point again because again. The price of oil is a little bit kind of mediocre right now, and we're a little bit worried about fracking and all the environmental consequences of fracking, and so people are reopening this discussion of going back to the Arctic Wildlife Refuge. But to be fair, it's probably only 6 months of U.S. supply of oil there, so someone's going to make a lot of money from it, but it's not really going to make a dent in our overall oil supply. So more recently, right, you guys should have heard about the Standing Rock Sioux Tribe controversy. That was actually just recently and came to close. But the Dakota Access Pipeline. So again, that oil we're getting out of the Bakken Formation that we're doing the horizontal drilling and fracking for. They wanted some pipelines to run from the Bakken Formation to a terminal in Illinois where it could then be transported to refineries. Okay, so the Energy Transfer Partners went through all the process of getting the permits and talking to the Army Corps of Engineers and identifying where to go. So in fairness to that company, they did everything legally and correctly, at least according to the information I could find. So there was really nothing backhanded or illegal or shifty about what they did. They did, however, want to build in close proximity to the Standing Rock sovereign land and water supply. And so the people of the Standing Rock Sioux Tribe Reservation began their whole protest process and saying, there's some legal things there as to whether or not the land that they wanted to go through was actually Standing Rock land or not. There were some arguments being made there. But just yesterday, the day before, they announced the Army Corps of Engineers pulled the rights there, and so Standing Rock for now won that process, right? So as of now, that pipeline will not be built through the Standing Rock Sioux Tribe land or the land adjacent to their tribe. So they're either going to have to reroute that pipeline or just halt construction for now. All right, and also recently the Keystone XL pipeline. Now this pipeline, if I'm ever going to get arrested for protesting something, it's going to be this one, because this pipeline connects to the oil sands up in Alberta, and there's no secret, I am not a big fan of going after that type of oil because the energy return on investment and the carbon footprint is just huge, and so there's a proposed pipeline connecting oil sands of Alberta to U.S. oil refineries. All right, it's controversial mainly because the pipeline was initially planned to be constructed over sensitive lands, and so people protested it from that viewpoint. But probably what it really comes down to, and the same thing with the Standing Rock thing, is it's not that those particular pipelines were dangerous, etc. It's that most people are just kind of protesting increased production of oil. Lots of people don't want to see that. Okay, and the thing with the Keystone XL pipeline is that it's coming from those oil sands, which a lot of people really, really don't like. All right, that wraps up what we're going to talk about in this lecture.